Mensuration. This is the calculation of volumes and surface areas or total surface areas of solids. A solid is a three-dimensional figure or shape, something that has length, breadth, and height. So in this exercise, let's start from question 1. The instruction says calculate the volume and surface area of the following solids. All measurements are in centimeters. So the first question here is a cube. The volume of a cube is length times length times length. I actually wrote this as length times breadth. It should be length times length times length, which is the same thing as L cube. So 12 times 12 times 12 will give us the volume. Then for total surface area, the total surface area of a cube is also 6L squared. So I should have written 6L squared, although it ends up being the same thing. This gives the total surface area of the cube. In B, the volume of the cuboid. Okay, the shape in B is a cuboid. Here, the volume of the cuboid is what? Length times breadth times height. So this gives the volume of the cuboid. Next is the surface area of the cuboid. The surface area of a cuboid is 2 into bracket length times breadth times length plus length times height plus breadth times height. 2 into bracket length times breadth plus length times height plus breadth times height. So we put each multiplication in a bracket and add after getting our answers. You fill these spaces yourself with the answers that should be there to get the final answer in bracket and get the final answer for the total surface area. That gives the total surface area of the cuboid. In question C, we have to find the total surface area. I think I can make this bolder by expanding it. So in question C, we have to find the volume and total surface area of this cube. All right, this is a cube. The volume is length times breadth times height, or length times length times length. So I'll do this multiplication first. After getting my answer, I'll now multiply my answer by 3x minus 1. So here, I'll do 3x times 3x, get 9x squared. Do 3x times minus 1, get minus 3x. Do minus 1 times 3x, get minus 3x again. Then minus 1 times minus 1, get plus 1. So I'll now multiply this answer by this second bracket to get this. So the total surface area of the cube is 27x cubed minus 27x squared plus 9x minus 1 centimeter cube. The volume is, the volume. This is the volume. So the total surface area is simple, 6L squared. So that gives what? 3x minus 1 times 3x minus 1. After getting my answer, I'll multiply by 6 and get an expression for the total surface area in centimeters squared. Here in D, this is a cylinder. The radius of the cylinder is 7 centimeters and its height or length is 21 centimeters. The volume of the cylinder is base area times height. See this as its base and see this as the height. The base is a circle, so the area of a circle is pi r squared. So the volume is pi r squared times 21. That will give you your volume. For the total surface area of the cylinder, the total surface area is the area of the top, the circular top, plus the area of the circular base. That's what? Pi r squared plus pi r squared. That gives 2 pi r squared. I hope you are getting what I'm saying. This area is pi r squared. The base too is a circle. Area is pi r squared. 1 pi r squared plus 1 pi r squared will give 2 pi r squared. So that's the area written here. Then the curved body, the body of a milk tin. If you remove the top and the bottom, what is left after removing the top and the bottom is the curved surface. The curved surface area of a cylinder is 2 pi r h. So if we factorize here, it's like having 2 pi r squared plus 2 pi r h. If you take 2 pi r from each one, this one will be left with r, this one will be left with h. So if we take that 2 pi r out, we have r plus h left in bracket. So my answer is 2 pi r open bracket, r plus h. That's 2 pi r times 28. You get your answer. Now, E, you have to look at this shape very well. First is to find the volume of the shape is cross-sectional area times length of the shape. So first, we need to find the area of this trapezoidal cross-section. Are you getting what I'm saying? So first, we need to find the area of this trapezium or trapezoidal cross-section. And to find that area, we need this height of the trapezium. I know the two opposite sides, 9, and this side, 13. But I need the height. How will I get the height? Very simple. All I need to do is, break this place into a right angle triangle like this. So in that right angle triangle, I'll mark the edge. Now, I know this place is 9 from here to this point. So this part too is 9. If I take 9 from 13, this place will be 4. So I can take out that right angle triangle. I can take out that right angle triangle, get h 4 and 15. So I'll use Pythagoras rule to get my h, since this is the hypotenuse of the triangle. You understand? H squared plus 4 squared is 15 squared. That will give me h as square root of 209. So I can now get my cross-sectional area, which is the area of the trapezium. Half open bracket, length, sum of two parallel sides, which is 9 and 13 here. You understand? This is the first parallel side, 9. This is the second parallel side of the trapezium, 13. So half times 9 plus 13 times h, which is root 209, times what? 8, which is the length of the solid, will give me the area. Sorry, will give me the volume. So I multiply all of these and get my volume. 9 plus 13 is 22. Half times 22 times root 209 times 8 will give the volume of, you put your answer here, of the solid. Now for total surface area, I have two sides that are trapezoidal. One is facing me, one is inside the book here. One is inside the book here, I can't see it. So I'll find those two areas like this, multiply it by 2. I'll find that area, multiply it by 2. That's 2 areas already. The shape has 6 areas. 1, 2, 3. That's the third area. There's another one here, 4. The one on the left, this one is on the right. Then 5, the base on which the solid is sitting. Then the top that's facing the sky, 6. So if I can find the area of each of those, I'll get my answer. First, I need to find the area of the two trapezium. The area of the two trapezium is what? 2 times half a plus bh. That's what I have done here. The area of the trapezium, half a plus bh times 2. One is facing you, one is inside the book. Now, the area of the top is 9 by 8. The top is a rectangular top, 9 by 8. Since this place is 8, this place is also 8. So 9 by 8 is the area of the top. So I'll find the area of the top, keep it there. The area of the base is what? 13 by 8. The base is here. The base is here, 13 by 8. That's the area of the base. This side is 13, this side is 8. So I'll find that to put it down. The area of the right side is 15 by 8. Right side, 15 by 8. So this side is what? 15 by 8. 15 by 8. I'll find the area of the right side. Then find the area of the left side. That's what? H by 8. And I know my H. So that gives me, my H is root 209. So root 209 times 8. That gives me the area of each part. 1, 2, 3, 4. 1, 2, 3, 4. Then 5, 6. 6 faces. After getting the area of each of these, I'll add everything up and get my total surface area for the solid. Let's go to the next question here. My solid is my solid is a prism, but its cross-section is triangular. This is a triangular cross-section. Let me mark that here. This is a triangular cross-section of the prism. So all I need to do to get the volume is get the area of this triangular cross section and multiply it by the length, 10 centimeters. So cross sectional area times length is the volume of the solid. How do I do that? I need to find the height of the triangle. Since I already know the base, which is 12, I already know the base. The base of the triangle is what? 12. The base is here, 12, but I need to find the height, h. How do I get h? If this side is 16 given, this side too will be 16. They are, the same side. They have the same dimension. So I know 16 here. I know this as 12. I take out that right angle triangle and take out that right angle triangle, h 12, 16, and try to get h 16, 12. So from Pythagoras rule, this is my hypotenuse. The side facing the right angle mark is the what? Hypotenuse. So that means h squared plus 12 squared is what? 16 squared. H squared will now be what? 112. So h is square root of 112. Keep that in mind. So your cross-sectional area, the area of this triangle, will be equal to half base times height, half times 12 times what? Square root of 112. You find that area of the cross-sectional triangle and multiply it by the length, which is 10 centimeters, to get your volume. You put your volume there. Now, the surface area is also very simple. First thing is to count how many sides or how many faces has the solid. If you count very well, the solid should have how many faces? 1, count with me, 1, the one facing right, then 2, the one facing left, which is at the back, then 3, this triangle here, then 4, then what? The base side on which the solid is sitting, making 5 sides. So we find the area of each side. There are 2 triangular faces, so 2 times half base times height will give us the area of those 2 triangular faces. One is here on this side, one is inside the page. One is facing me outside here, one is, lying inside the page, facing the other side. I can't see it directly. So that's, 2 surfaces already. Then there's a side that is 12 by 10. One side is 12 by 10. This is the side, 12 by 10. That's the base on which the solid is sitting. This side is 12, this side is 10. So that's a rectangle. I'll find that area. There's another side which is 10 by root 112. That's the left side there. It should be what? This side is 10, so this side is also 10. Since this is a rectangle, so I have 10 by what? 10 by h. 10 by h. This is also h. So this rectangle has dimensions h by 10. This is 10. This is 10. This is also 10. Yeah, it's also 10. So that gives me what? 10 by root 112. Then there's another side that's 10 by 16. That's the 5th side. 10 by 16. This side, 10 by 16. So that's the 5th side. So take note of each side. 16 by 10. That's the 5th side. So I'll add up the area of each side, get my answers, add everything here, and get the total surface area. That gives me the total surface area of the solid. G is a bit technical, but if we look at it very well, we should be able to get it easily. Let me break the solid into 2 parts. If I break the solid into 2 parts, I'll have part B, which is up here, having dimensions, this, dimensions 1, okay, height, breadth, maybe, length. Or let's do it this way. Let's call this the height. So I can do it anyhow I like. Anyone can be called length, breadth, height. Just make sure you don't mix it up. So this is my length, this is my breadth, this is my height. So from the diagram you can see my height is 4, my breadth is what? 8.5. It's written on this place where I've written B. And my length is what? This is 6.5. This part is 6.5, this part is 6.5, so this place too is 6.5. So my length is 6.5. So I'll get the volume of B like that. How do I do it? I just do 8.5 times 6.5 times 4. get the volume of B. Can you see? 6.5 times 8.5 times 4, like length, breadth, height. Do you understand what I'm drawing? Let me write that in red so that you can see it. Length times breadth times height. Or should I make it black? Length, okay, yellow is okay, times breadth times height will give me the area of this solid. Or do it this way, height times breadth times what? Length. Do you understand? That will give you the area of that part B. Then the second part, which is, part A, on which the B is sitting, has length. What's the length? 10. What's the breadth? 6.5. What's the height? 1.5. So you add 10 times 6.5. 10 times 6.5 times 1.5 is the area of A. You find the answer to these two, add both, you get the volume of the solid. I think I've written that in the steps in this answer correctly. So that explains how we got the volume. Now, let's go to the surface area. The total surface area is very simple. All you need to do is take note of every side that's available. So let's start from this part. This part is, 1.5 by what? 10. This place is 1.5. This place is 1.5. Okay, let me use yellow so you can see it well. This side is 1.5. This side is 1.5. This side is 10. So 10 by 1.5 is one area. You keep it. 10 times 1.5. So keep that. 10 times 1.5. There's another one on the other side. Another 10. There's another 10. There's going to be another 10 times 1.5 on the other side. You keep that too. Then this side, this face is 6 times 1.5. No, 6.5 times 1.5. Keep that too. This one. 6.5 times 1.5. Then keep the base on which the solid is sitting. The solid is sitting on a base that has 10 by 6.5. So let's keep that too. 10 by 6.5. You understand? I'm counting areas. 10 by 6.5. Let me write it here. 10 by 6.5. Then keep this side too. 6 by what? 6.5. Can you see this is 6.5, this is 6.5. So this is 6. 6 by 6.5 too for that area. 6 times 6.5 for that area too. I think I'm going places now. Then I'm going to take this one too. There's another face here, 8 by 8.5 by 4. 4 by 8.5. It's right on top here. So I'll keep that too, 4 by 8.5. I think I'm coming close to the end. Then there's a face standing here, 8.5 by 6.5. If this place is 6.5, this place is 6.5, this place too is 6.5. So there's an area there too. That is what? 8 by 6.5. So let's do that. 8 by 6.5. So that gives me the area of that side. Now there's an area here too. That's not showing, but it's there. It should be like this. It's facing your left side. That area is 10 by 6.5 also. It's a long standing area, 10 by 6.5. Let's do it, 10 by 6.5. Then there's another area here. That's what? 4 by 8.5 here, 4 by 8.5 here too. So I can just put 2 at the back of this one. You understand? I can just put 2 at the back of this one. Do you understand? So let me put 2 at the back of these two and clean this. So I don't have to repeat anyone. That's the same. So I think I'm coming close to the end. There's another area here that is 6.5 by 4. So 6.5 by 4. That's the top area. 6.5 by 4. Then lastly, Lastly, I've done this, I've done this, I've done this, I've done this, I've done this side, I've done this face, I've done this, I've done this face here. Okay, 8.5 by 4, I've done. So that's all the area of the shape. That's all the area of the shape. So you add up everything and you get your answer. The solution is at the back here. So we have counted together now. Let me show you where the solution is. The solution is right here, how I did it. So you add each of these answers and you will get the total surface area of the solid. Now, question H is straightforward. Volume is base area times height. The area is a circle. The base is a circular base. The solid has a circular base since it's a cylinder. So pi r squared is the area of the base times the height 15 will give you the volume. Your answer will be written here. Total surface area is 2 pi r squared plus 2 pi r h, like we did in the previous cylinder. So this one is half a cylinder. This is half a cylinder. It's like cutting your cylinder into two. It's like what you would get if you were to cut this into two. So it's a very simple question. The volume is just half the volume of a cylinder. That's half times, that's what half times pi r squared h. So, put the values. The diameter is 7. Radius will be diameter over 2, which is 7 over 2. That gives you 7 over 2 times 7 over 2, where radius should be. You put your answer here. Exactly. Then the surface area is simple to find. There's a semicircle here. There's another semicircle here. So that's 2 times area of a semicircle, which is half pi r squared. Then there's a rectangular base on which the solid is sitting. That rectangular base is here. That's what 7. That's what 7 times what 13. You understand? That's another area. Then the area of the curved body. The area of the curved body, or the curved part of the cylinder, will be equal to half the curved surface area of a cylinder. So half the curved surface area of a cylinder will be the area of the curved body. So look at it here. Half pi r squared plus length times breadth plus half times 2 pi r h. You understand? This is half the curved surface area of a cylinder. The curved surface area of a cylinder is 2 pi r h, but this one is half a cylinder. So half times 2 pi r h will give you what? Pi r h. So that gives you the total surface area of the solid. You put your answer here. Is that clear? J is very simple. J is very simple. It has different parts like the previous solids have 4, 5, 6 parts. So here, you just have to count the parts well. First is the volume. Let's get the volume. This is 10. This is, angle 25. So I need to get the height of this triangle. H sine 25 is h over 10, opposite over hypotenuse. So h is what on cross multiplying? H is 10 sine 25. I'll keep that. I also need to get the base of the triangle. Cos 25 is what? Adjacent over hypotenuse, which is 10. If this side is 10, if this side is what? 10, this side too will be 10. If this is 10, this side too is 10. That's how I got my hypotenuse. Hypotenuse is the side facing the right angle mark. So cos 25 is what? B over h, b over 10. So if you cross multiply, what do you get? B is 10 cos 25. So the area of this cross section of the solid is half base times what? Height. You understand? So the base is 10 cos 25. The height is 10 sine 25. So half base times height is cross sectional area. Half base times height times the length. The length is 8. So that gives you your volume. Now after getting the volume, we need to get the total surface area. So the total surface area will be area of the two triangles, 2 times half base times height, then you know, the area of this rectangle 8 by 10. There's a triangle here, there's another one here, so that's area of the two triangles. Then this side that is 8 by 10, that's the side, oh sorry, this side that's 8 by 10, the side facing you. So then this side that is what, h, this side is h by 8, h by 8. So that's the side, you know, inside the book. Then 2 times half base times height, 8 by 10, then 10 times 8, then 8 by, you know, h. You put all the values together. These are 5 areas, 1, 2, you understand, there's 2 here, 1, 2, 3, 4, 5. So you put all the values together, get each of the areas, and get your total surface area. That's the solution to all the questions in number 1.